Hello, Algebra 1. Chapter 1.5 teaches you how to turn phrases that people say into algebraic expressions and how to turn sentences they say into algebraic equations. It starts at the very beginning with a table like this. The very top row of the table is all about some different verbal phrases that have addition operations in them. And so what they suggest, and I've highlighted it here, is that you look for the words that indicate the operation. So each of these, whether it's sum all the way down through increased here, is trying to indicate that there's a plus sign happening. There's one of these that I want to highlight in particular, separate from the others, this more than statement, because we're going to come back to this, and I want to make sure that I make it clear exactly how the wording is stated here, because I'm going to distinguish that from another way that's very close. The other thing I want to point out in that top row is in each case they simply say a number, a number, a number. But notice over here, first time they use an X, but the other times they use other letters. Well, when it's a number, and we're turning it into algebra, you can turn it into any letter that you like. So for example, I'm going to have you do 7 more than a number, and I'm going to let you pick whatever letter you want. Go ahead and hit the pause button, and when you come back, we'll check and see whether your answer matches mine. Okay, I'm going to assume that you did that, and I came up with 7 plus P. I picked P for pine, but maybe you picked a different letter. But wait a second, you might be saying to yourself, looking back at the table I just showed you, when it said more than a number, it had y plus. So should it be p plus 7 instead of 7 plus p? Is there a difference between p plus 7 and 7 plus p? Well, there's actually a paragraph at the very bottom of that table. I've covered up one part of it, but the bulk of it here is this statement here, that order, although it's important for subtraction and division, order is not important for addition and multiplication. So, as it says here, 6 plus x and x plus 6 are both fine. Either one is fine. So same thing here, 7 plus p is the same as p plus 7, and it doesn't matter which one you picked. Now we move on to the next row in the table, subtraction. Once again, they've picked a number of words like difference and less than that are all indicating the operation subtraction. And again, I want to highlight that paragraph. But this time, I've got to uncover that phrase, because now order is important. As I've highlighted here, whoops, didn't mean to move it. As I've highlighted here, if you have the phrase 4 less than a number, that's x minus 4. It's not 4 minus x. So here, let me see if I can think of a way that might help you remember this. Okay, well here's an idea. Let's say the perfect score on a test is 100. And let's say that somebody said that you got 4 less than the perfect score. Well, that would be 100 minus 4, in other words 96. That's not going to be 4 minus 100. You didn't get a negative 96, you got a positive 96. So that's why it's x minus 4, not 4 minus x. Okay, the next row in the table is the multiplication row, where they come up with words like product and times and multiplied by, each of them indicating multiplication. So the point that I'm trying to get at with each of these rows in this table, and the point that the authors are trying to get at, is that there are different words people could have chosen to use in their phrases, but all of them end up being translatable into algebraic expressions. Let's go back and remind ourselves, if we need to, about the difference between an expression and an equation from a couple of lessons ago, where we said an equation has to have an equal sign, and an expression is a collection of numbers and letters, and there might be some operations in there too. Okay, last row was division, and they just give you 2 different words to choose between. The one that's obvious, divided by, and the other, quotient, which you don't hear people use very often. But once again, remember that order is important for division. So if you do hear somebody say the quotient of a number and 4, the first thing, so let's say it was the quotient of 5 and 4? Well, the first thing that came up is the one that's going to go on top, so it would have been that 5 on top. Just like the first thing here, 7 divided by a number, is 7 on top, 7 over x. They take that then the next step in the first example, and they start turning slightly more complicated algebraic expressions. Whoops, moving it again. Turning those into algebraic expressions. So the first one here, 3 more than the quantity 5 times a number n. Clearly a more complicated expression than we said before, I mean a more complicated phrase. As they say here, think 3 more than what? 3 more than, well, 3 more than this thing here, the quantity 5 times a number n. 5 times a number n is simply 5n. 3 more than 5n, you could have said 3 plus 5n or 5n plus 3. Either way would be fine. For b, 2 less than the sum of 6 and a number m. Well, once again, think 2 less than what? And the what is this whole long thing here, the sum of 6 and a number m. So they actually wisely put that in parentheses to make it clear that this is a group. The sum of 6 and a number m is a group. And then you're doing 2 less than that thing. So once again, it's 2 less than what? And the last example here, a number x increased by the sum of 10 and the square of a number y. Well, it's quite a mouthful. Well, first of all, it's going to be x decreased by what? And the what is a long, complicated thing here that's probably going to require at least parens. And sure enough, x decreased by. Well, remember, decreased by, this thing comes first, then decreased by is a subtraction operation, and it's decreased by this group here. And they've put parens around the group. 10 and the square of a number y. Notice the square only is talking about the y. They don't say it in a way that indicates that 10 is being squared. Only the y is being squared. And that's why they have 10 plus y squared with the exponent only next to the y. Okay, the next step is to figure out how to use these. And this is goal 2, how to make use of these phrases which become expressions to actually do some algebra work. The first thing to notice here is this distinction here. I know it's a small highlight, but it's an important point. When they add the word is, notice that the first thing here, which they call a phrase, and the second thing here, which they call a sentence, are the same moving left to right until you get to this point. And then you have the word is. Is means equals. So just kind of get used to that. Is and equals are the same thing. So same expression here and here, but remember an equation is 2 expressions with an equal sign in between. Is that equal sign, and there's your other side. Now, they go one more row here, and they talk about inequalities, is less than. And instead of an equation now, we have the arrow that indicates is less than. Okay. That brings me back to something I said I was going to come back to. Remember I said I had to get very specific about some wording. It happens that this time they talk about less, and the time I talked about it before it had been more. But I want to get more at the point here of why isn't this showing an arrow? Why isn't this a is more than inequality? Well, it's because there's no is word here. For it to be an inequality, you need that word is less than, is more than. We don't have that. If it's just the words 8 more than, that just means plus 8. If it had been 8 is more than, then you would have the number 8 and the inequality arrow. An important difference that might seem very small just because is a short word, but it's a very important difference. Okay, so now let's try applying these. 6 less than a number. Hit the pause button and write down what you think that is. Okay, I'm going to show you what I wrote down, and I hope you wrote down the same thing, whether you picked a different letter, x, for example, x minus 6, but it should be a letter minus 6. All right, now the next step, basically the same thing. 6 less than a number is greater than 10. Hit the pause button. All right, here's what I did. P minus 6, and then is greater than, that's this arrow, and the 10. Okay, from here on out, I've just got a bunch for you to try. Work on that one while you've hit the pause button. I'll show you the answer in a second. Okay, that's what I came up with. You can always hit the pause button and study it if you don't have the same answer as I have, but if you haven't hit the pause button, we're going to move on. Here's another one. Hit the pause button, and I'll show you the answer in a second. All right, here's the answer. And now we're going to move on unless you've hit the pause button to study it. Here's the next question, or the next challenge. Write that down, and then write down the algebra version. And there's the algebraic version. One more. And here comes the algebraic version. Notice that this time I've highlighted the words we haven't seen yet because it says greater than or equal to. Well, remember, I'm sure you've learned about inequalities back in middle school. Greater than or equal to is that same arrow shape, but this time underlined. Next challenge, we only have a couple more. Okay, I'm going to assume that you paused and that you did this one, and here is the answer. And here comes another one. And then here comes the answer. Okay, this is the last of these challenges. See if you can get this one right. Okay, I'm going to assume that you paused and did that one, and here's the answer. Okay, and now that you have the answer to the last one, here's the homework assignment. This is the same homework assignment, This is the same homework assignment that I gave you after the quiz. So if you copied it down after the quiz, then you already know this. But if you ran out of time, then I want to make sure that you have it here. I'll see you in class.